Thank you for coming so early this morning. Let's start diving in this. Why I'm giving this talk and who I am. I am Juanmi, work for Veturis, but connected with submarines. I work also with Andalusea. It's a company located in Málaga, and we dive submarines doing operations with them. In the meantime, I'm also doing a course of quantum computing, and I already talked about submarines last year in Ubuntu Summit in Riga. And also, I am part of the core team of OpenSouthCode, this venue that is happening in Málaga. This year is happening in between 20 and 21 of June, or 2025, I mean, next year. And you are all welcome. So let's talk about submarines. Let's dive in. We have to make a difference between a submarine and a ROV. A submarine is something that people can get in, humans are controlling them from inside, is to take humans somewhere. While a ROV is a remote controller. It's operated from the outside, usually from the ship or from the sea or from the port, but there is nobody inside. People tend to think that the submarine is big and the ROV is small, but that's not true. I have here an example of a small submarine and a really big ROV. By the way, it's a great channel that you should visit. This ROV especially is for Nautilus, and it can dive until 4 kilometers depth, and it weighs around 2,500 kilos. So it's quite heavy, and it needs two people to control it, to manage it. There is a pilot, an engineer, and a navigator, somebody that is saying where to move and how to go. First thing, when you get to build a submarine is to choose a frame, to choose the shape it's going to be, how big it's going to be, which kind of movement it's going to have. So in the beginning, we started talking about the 6 degrees of freedom. Usually, ROVs, they don't move in any direction or position. They usually don't do pitching. They just dive down and up, but they cannot pitch because it's not necessary. We have a camera, and the camera can look down and up. So depending on the configuration, you will need more power. You will have different kind of movements. It will be more reactive or less reactive. Can bring up heavy objects or not. So this is the first step. Then you have to think about ballasts and buoyancy. It's a basic thing when you are getting to water. We have a ROV here, and it has balance if I keep it or I put it somewhere. But when you put it in the water, things change. The water is a different environment, and it doesn't work in the same way than outside. So in the left picture, for example, you can see that the pressure on the bottom is higher and down the top. And we will have to work on that. We have to manage and decide where to put the ballast and the floats so the ROV will be stable. Usually, we look for zero buoyancy. Means that the ROV will stay in the water at any level and won't sink and either go up. And for that, we need to know a little bit of theory about the Archimedes principle and Boyle's-Mayrot law. The Archimedes is simple. When we put an object inside the water, it is displacing an amount of water. So the weight of that amount of water is the force that is pushing our object out. So if we are putting an object inside of the water that is displacing, is taking out 2 kilos of water, then there is a force of 2 kilos pushing up. So if our object weighs 2 kilos, it's staying stable. If it weighs more, we sink. If not, the opposite will go up. And because of the pressure, we have to think, we have to focus also on the Boyle's-Mayrot law, which talks about the pressure. And under higher pressure, the air tends to compress. So when you get compression on some object, it reduces its volume. So we have to come back to the first one again. If we reduce the volume, we lose the buoyancy. So it is important to keep the shape so the object won't sink after a certain pressure. I mean, we won't reduce the volume. That's how it looks at a bottle of air from the surface when you dive it 10 meters. You can imagine it divides its size. Actually, you have here the relationship When you pass from 1 atmosphere to 2 atmospheres, that is 10 meters, the volume of air is reduced by the half, which is a lot. It's happening, the most change of pressure is happening at the beginning, the most on there. So it's important to focus on sealing and the material strength and usually on this world, people don't tend to think about fatigue of the objects, but they actually suffer. After one another immersion, the objects are getting little bit broken, and they can get leaks and things like that. So you have to focus on doing a proper maintenance to your ROV. The motive of this is because in 2018, I decided to make my own ROV, and this is it. It was in the beach. And I already knew about the technology that I'm going to explain now, but I didn't want to spend any coin on that. I would prefer to do it all by myself. And this is actually what happened to these people. Chris Anderson and his son, in 2007, they had actually the same situation that I had. Mine was with submarines, and they was with drones. So in 2007, they started working with Arduino, and they made a software that was able to manage drones. Then they met Jordi Muñoz, which was working in the moment with Nintendo Wii controllers. So he was already knowing about accelerometers and gyroscopes and things like that. And he brought that technology to it. And they together built the first version of Ardu Pilot. And together with John Callahan, which brought mostly the business side of the project, they made do-it-yourself drones. And that was through Ventures, that is an investment capital company. So finally, 3DR is what is now. It's a company that is selling these products. And here is one of the versions. It's what I'm holding now. That could save me several years of my life instead of making my own Arduino. That was it. So I'm explaining you so you save that time yourself. So in 2009, there was a first version, then they moved until several versions, and in 2013, we had the first version. This is the one I'm holding in my hand is 2.4.8. So it has, you can see the photo is quite similar to the first, to the one that is on the screen. There are many versions of Ardu Pilot. Ardu Pilot, the hardware, and you can look for any purpose. But the main connection between these two worlds is that when was Ardu Pilot built for drones, actually, in somehow, it was similar thing for a ROV, for a submarine. The only thing that was changing is that while in the air with the drone is flying and you can send signals, radio signals, to the water you cannot. So we just use a cable. And that's the biggest change of it. There are some more that we will explain now. So that I made to appear ArduSUV. ArduSUV is a combination of Ardu Pilot software, but supporting ready for submarines. And we install it in Raspberry Pi, usually Raspberry Pi 3B and Raspberry Pi 4, but as much as I tested, it works in every kind of Raspberry Pi. I mean, the newer versions. Another thing that we are going to, I forgot to mention that Ardu Pilot is free, open source, as ArduSUV. So another piece of software that we are not going to need is Ground Control. Ground Control is open source, and it's a software that when I was making my submarine, I was building my own environment for controlling my ROV and everything. And then I discovered this. I say, why I don't just adapt and stop doing myself a software? My business was to make my hardware, not the software. So what this Ground Control is the thing that is giving us all the control of the ROV. So that's the core of the system. That's the secret. It's the computer connected to the Raspberry Pi through USB connected to the PHOC, which is the hardware. And we will be connecting things to one or the other. PHOC is an ARM, Cortex M4, and it has many connections. There is a part of analog connections, that will be here, digital connections, even signal. The RC is the radio channel, so to send and receive radio signals. You know, it has what is it? It has a SPI protocol. You can set the buzzer that you will see in this rod that is here. You will sound. You can connect to GPS because actually when the ROV is outside, you can get position. There isn't much point, but you can. Most of it is that. So we will be connecting few controls here. We will connect into the power connector. So we can control how much energy the ROV is spending and how much voltage we have left in the battery. We will connecting also the depth sensor to it. That's it. And all the rest will be going connected here. The thrusters, the camera control, and all the rest. So the first step that we have to do in the PUHack is to install something that has a SSD card behind, and we connect it to QGRAM control. That will take time. It will just install. This one is already installed. And once you connect it to QGRAM control, it will be able to give you positioning and compass. How that happens? That happens with Mablink protocol. Mablink protocol is a simple protocol that is communicating the PUHack with the computer with QGRAM control. That's the video. But I will show you how this works. So I'm going to plug the USB. I connect it to the computer. And I will start QGRAM control. And you will see my screen. I can get my laptop? OK. So you see, if I turn forward, backward, anything, everything is really, really reactive. It's not, you know. So when we are diving, this is what you see. What is missing here? The depth sensor. And you have already the position of the ROV. OK? So let's come back to the talk. OK, so Mablink, this is Mablink. This is the protocol. This is what I designed in my ROV. My Arduino version, and basically it has, this is the version 2, that's version 1, and the most important is that it's kind of like a campus, it's multi-component. So you can have several components, each of them they understand how the protocol works, and they will be attending when the messages are getting to them, are for them. It's important to say that there is encryption, signature system. And that is in the back, actually, the Mablink, what QGRAM control works with the Ardu pilot, sending a heartbeat at 1 Earth is pretty big, quick, so it can work slower, but it keeps the connection, and that lets the software to work that fast as it's doing. And then you can send signals, including, for example, planning. You can set a plan, you can set the plan to the ROV, and the ROV will be doing that plan through the software. So how you can imagine what it's doing here, that it was the first scheme that I showed, the core of the system. What it's doing, the Raspberry Pi is bypassing the messages between the computer and the PUHack. So what's the Raspberry Pi 5 for? We will see. Also, you have the possibility to make a bridge between Mablink and ROS protocol. So you can use QGRAM control with ROS systems in the case that you have some submarine that you want to build with a different protocol. Another of the elements that we need is a Raspberry Pi. Probably you know already of you. So we just install and get it ready with the software, with Arduino, that we just download and install it. So what gives PHAC to add? It gives telemetry, which I already showed, control for outputs, thrusters, pressure control. You can have also temperature control and sensor, and a servo camera. This is what PHAC is giving at the first point. So what do we need ourselves is to add lights, camera, leak sensor, depth sensor, and the hull and the frame. Actually, I wrote here lights. Lights can be moved to the PHAC. So it's up to you, the configuration that you prefer. Definitely, camera is connected through USB and so on. OK, let's go. What you see here is already the capsule of this ROV, what you have here. So this is what keeps the pressure. I don't know if you can see on the side, but there are two of them. So one is keeping the circuits, the Raspberry Pi and the PHAC, and the other one is having the battery, something like this. I was looking for the PHAC, it's here. So all of this is in one place, and the battery is in the other. And they have the cover, and that's simple. One is connected with the other, and between both of them there is a umbilical cable. So this is the basic configuration that you have on the top of the line of the water. When you are on the ship or somewhere, on the port or the beach, you have the cable, and the first thing that you need is to control the ROV. So you have the kind of PlayStation controller. I did it work with the PlayStation 4 controlling, and it was fine, just fine. So connect it to the crew and control your computer, and then it goes to into the connection box, which is actually an Ethernet connection to the underwater, to the ROV. So you have here the role of cable, which is nothing to explain. So let's see what is under the water. Under the water is coming the link of the cable to the connection box, and is bringing the network connection, the Ethernet connection to the Raspberry Pi. So when we are outside, the only communication way to the ROV is through Ethernet. That gives us a link for the camera, and if we are bypassing MAVLink, we are getting connection through the DSP to the PHAC. So we know already that there is a MAVLink protocol, where MAVLink bridge working inside, bypassing messages from one to another, and the camera that is USB. But that's not enough. We need more things. We need to move a ROV, we need a thruster, and that you need an AST. AST is something that we have here. So it's this piece of hardware, and it's responsible to control the speed and the direction of the thruster, and the power that we're putting into it. So it has two connections. One for the electricity as itself, and one for signaling, for saying to the thruster if we are going forward, backward, or which more power, less power. So this is one of the parts. I already showed the camera on the screen, which is this one. It has two servo engines, motors, so it's able to move up, down, left and right. So they will be part. I'm connecting the camera through the USB. What else do we need? So we need a power supply and a power sensor. So we'll be in 2 steps. These are these. This is a power sensor, which just get the electricity and measure how much electricity we have left on the battery and how much we are using from it, and will be plugged to the PHAC, which I'm plugging now. So I will be plugging things here. OK. We already talked about the thrusters. So I'm plugging in behind. That is a position for minus ground signal is always on the top in the PHAC. and signal is on the bottom. We are taking off the voltage because we will be giving it. We are going to give voltage through to the PU by the power module. What else do we need? We will also have the leak sensor, which is I2C. I don't know if I can see it. Okay. So this is the leak sensor, the pressure sensor, sorry. I will measure how they are going. What's another important part of the, we already showed before, is the power supply. This is changing, stabilizing the energy that we are giving to the rest of the system. So Raspberry Pi and the PU, they have to be behind this one, in front of the battery. So what I will do is connect it to the, after the power sensor. So we are already see that we'll have a battery here, bring electricity to the power sensor, which is going to the PU hack, and then we will distribute the energy to several places. Yeah, one of these places is here, is 5 volts, and is giving electricity to Raspberry Pi and to the PU hack. So I'm going to plug it right now. The connection place is in SB connector. Here we go. And that's the moment where we had to plug the Raspberry Pi, which is over here. The place to plug the Raspberry Pi is connecting to the last pins number 2 and number 4, which are giving electricity through the pin systems. So in this way, we leave free what is the USB connection for our PU hack. One thing else that we need to connect these two is plugging the USB to the PU hack. And put it together to the Raspberry Pi. What else are we missing? We have this piece of hardware, which is a leak sensor. Can we show again the screen? So I will show these elements. OK, great. So what I already talked is about the thrusters, which is the IST here, is a speed controller, the pressure sensor, the camera together with the servo, an UVEC, which is the power stabilizer, which is already installed, and here is the leak sensor, is something like that. So when this gets wet, it gives a signal to the PU hack saying that we have a leak, and actually make even a noise sound. The power sensor, and finally lights. OK. So let's come back to the table. And we'll connect, I have configured this to pins 3 on this position. OK, so we are. What else are we missing? We have the servo, and the servo is controlled in the PWM connections that are in the end. And remember to put the ground on the top, the power in the middle, and the signal bottom, or you can burn the circuit. So once connected, we are ready. And of course, no camera without connecting to the USB of the Raspberry Pi. And we didn't connect yet the electricity to our thrusters. So the thing that we are going to do, I brought this. We don't need it for this specific scenario because I only brought one thrusters. But in general, you will be plugging more than one of thrusters. So you will use several of these to bring electricity to them. The only thing that you have to make sure is that the connection is passing through the power sensor, so we can measure everything what is going on in our system. Okay, so we'll plug the battery, it will measure, and all the rest of the system is behind. Not forgetting that we have to stabilize signals, electricity for the Raspberry Pi and the P-Hack. So I think that this is all. Let's plug the connection to the computer and the Ethernet connection to the Raspberry Pi. And that's the last thing that we need to do before powering on. I won't do a second checkout here now, but usually what you have to do is to do it, to make sure that you didn't mess up anything. And let's go for it. It sounds good. OK, so now let's connect to my laptop. It will take a while, because here I was one specific version of Arduino that is working with Docker, so you can switch from one version to another on the fly. So if everything goes fine, it will go through. Let's go back to the presentation, and then once ready, I will keep talking about this one. One important thing about the ROV under the water are lights. It's a game changer. Usually we tend to record under the water with any camera, and you get this situation where it's a lot of blue and greens colors in your recordings. So bringing light, it's a game changer, as you can see. So it's something that you really need to have and to think about when you are making building a submarine. That's our final picture. This is what I did. It's the pressure sensor. This is the power module sensor, the ISC, the power supply. This is all connected. This is connected with this one. Okay, they are the same. Raspberry Pi, USB, and the link to the top to the controller. Okay, so let's see is it working already? Anything can fail. Lady 50. As you can see, the camera is already moving. What else? You can hear the thruster. I'm controlling through my remote controller. And the leak sensor is working as well. So this is actually what the submarine has. There's no more. I don't have probably the camera signal. I don't know if I plug it good or not, but it doesn't matter. I will show you in the other row as well. OK, let's go back to the... you have some question until this point. You can already make it. So?
Thank you very much. It's so interesting. Why do you have a Raspberry Pi and a Pixhawk? Is there any material merged? Does it exist?
Sorry?
Why do you have two devices, a Raspberry Pi and Pixhawks? Arduino ones. Is there any material which combine both components?
Yeah, but of course, you can find some computer that gives you all the digital signals to do that. But you have to compile, change the
the firmware?
the software that's working. The Arduino Pilot, you will have to migrate it to some PC or something to have a stronger. Because this Arduino is not strong enough to manage the video signal, for example. So you need something better. In my ROV, for example, I decided to send the signal like you would do in a drone. I took the the analogical signal straight through the cable up to the top line of the water, and then from there I was using a meter, like a 5.4 gigahertz emitter, like a normal drone, and was getting my signal to the Googles and the laptop and things like that. That's one way, but it's not the common. Usually you do this because you can record the videos and things like that. I was trying to work on bringing back this air signal back to the computer, so I was able to record it, but I didn't finish it. Some more questions?
Hi. What's the difference between a submersible versus a submarine?
The difference between the submarine and?
Submersible.
I don't know. I don't understand.
Like, if you know the Titanic, the Titan submersible, like how is it different from something that's connected to a wire versus a wireless?
Because you cannot communicate from the top line of the water, you cannot communicate to the submarine. Since these ROVs are not human are getting inside. You are just sending the submarine. So if you cannot communicate with it, you just have to set up a cable.
It's just an ROV.
Sorry?
ROV, remote operating.
Yes, total. Yeah. I don't know how much from these guys that were going to the Titanic, they were using this kind of technology, because this is not too far from that. You can do that. You know, what I have been doing here, you just take it all inside your own submarine capsule and you just get water. I wouldn't do it. But yeah, I prefer to send these things. This cable, for example, is such a small and has 300 meters. So, real. This ROV can stand have been diving around 50 meters. We have another, the one that is bigger, and it went to 150 meters. The Gibraltar Strait between Spain and Africa was 100 meters, more or less. We were looking for an anchor that was lost from a ship, so that was one of the missions, and that was one of the places that we worked. Okay, some more questions? So let's keep going. Okay, what is under the hood? This is software. We like software. So what is here, I made it in the box, is what PHOC is doing. Okay, so you have here the Raspberry Pi, which is connected to the top with the computer, Q-ground control, and using the video stream and audio stream, okay, with UDP sync, is sending the signals through these two ports to the Q-ground control. So it's doing like broadcasting. It's sending packages, they are UDP, and they are being sent all the time. When I plug it the ROV, it's just sending, and the Q-ground control is getting from it. Usually, there is information in the Mavlink connection, which is here. Here is PHOC, and it's connected to the USB. So it's using Map proxy, is sending packages also by UDP to the Q-ground control. In that packages, there is information about which is the port of the camera. So when you make configuration of the ROV, you just save it inside the ROV. And when the ROV is going, the configuration is going with it. It doesn't depend on the software, on Q-ground control. You can plug many other things that are here, like ping scanning 300 sonar, 360 sonar, etc. On some point during my development of my ROV, I was working with making software and things like that. And Arduino was a little bit a mess. As you saw before, they were working many pieces inside it. So I was planning to put everything together, but Blue Robotics, which is, in my opinion, is the leading company right now in this market, they share with the community BlueOS. And BlueOS is actually Arduino, but packed with Docker images, and they are delivering with upgrades. It supports plugins, it supports configuration, this is how it looks like. So before we didn't have any website like this to control the ROV, to make configuration, to know this is what's happening inside queue and control, and that was the only communication way to the ROV to send configuration. But they also made something like this. This is a web, okay? This is web technology. So you can configure it your own screen, and you even don't need queue and control anymore. You just have to plug it and go on with it. I tested and was great. So you just make your own configuration, and you play. You just take the water and route to the water. You don't need anything else. And of course, anything that you need for your ROV, you have to say, in this connection in the PHOC, I have connected the sensor for the depth, I have the sensor for temperature, so you have to be making this configuration. And also about the thrusters, I don't know, it's here. You can set the gripper, check the monitoring of the battery. There are alerts, so when you are under some levels or over some levels, the ROV can behave in such a way it can come back to the surface, it can send a signal, whatever. And now questions. Some more questions? So let's get back to my screen. Okay, so this is the ROV, and this is a normal ROV. This is actually nano version. So now it's working in manual. You have to take care when it's armed. I don't know if I put highlights. Yeah. So you can get lights. You can control the camera. This is it. It's the same thing that is here inside is here outside, with the difference that the camera is going only up and down, but this one also has sides. But this is one design decision. So I think that this is all. Disarm, and we are ready. Some question? Okay, so thank you very much for being here today, and so early.
Thanks a lot for your talk. How long did it take you from the first idea that you want to build something like that to the first working version which you actually could use in your pool?
Okay.
And maybe also, apart from that you're living near the beach, what was your motivation to create a submarine?
Two great questions. To the first one, it took me 4 years, and I will give you bigger description now. And the second one, the motivation, which is actually the first thing that we spiked the idea and start doing it, was because I have a friend who can have problems with ears and cannot dive to the water, cannot see under the water, but he wished it. So I decided, okay, I have this knowledge, why not to try? And that's what started all these things. It took me 4 years because it was pandemic in the middle. I was from 2018 and 2018. I was starting learning. I remember in 2018 I bought my first Arduino maybe in October or something like that. So I didn't have any knowledge of electronics. That was the thing. You have to start. You think that you buy a kit and you will have the submarine. It's not like that. But on the first point, yeah, why not? And then came pandemic. Pandemic changed everything. I started working on it. I got married on 2020 also. And on 2001, I stopped me one specific problem in my submarine. My submarine was working with, as I said before, there is a cable that's going to the top line of the water, and everything from there is wireless communication. So the video signal is wireless, but also it was connecting to 4G cell phone connections. And I have problems to start up the module, the GSM module, because it needs a specific spike of energy in the beginning, and nobody, even I was asking friends in university and teachers, and they didn't know how to tell me that I needed to put a specific supercondenser there, supercapacitor, sorry, I'm using Spanish. So to set up this supercapacitor, so I will pass that. Once that was done, it happened the rest, and it just came one after another step. I don't know if I answered your question. Some more questions? Yes?
How does it handle turbulence?
Yeah, that's a good question. As you saw, PHAC is working. I will unplug it so I can show it. PHAC is, you saw that it's working pretty fast. So there is one mode that you can set. I could do it here in my screen with this one. And actually, can you give me the screen back? I can show you. Okay, when we are working with it, there is one mode which is stabilize. And the rope will try to keep the depth. Now it's trying to sink. So that is the reason I started. But in the stabilize mode, yes, this arm, when the rope is being turned to one side or the other, it's correcting by itself. So these are situations that you can get a deep hold, for example, if there is a lot of buoyancy, and it spends more electricity, but nothing so important for that. And one thing more is positioning. It's a different thing. One thing is to keep the stability of the rope, but positioning, you need a US BL. In the new version, we are making a new version of our rope. We'll have it, don't have it yet. And that is connect to the chip and get information about where is it. Together with the chip, it's taking GPS signal, it can tell you where is the rope under the water. We were using some product in the past from Blue Robotics also. There was Waterlink, which is actually a big antenna that you put in the water and everything, but it didn't work. It wasn't, wasn't very sensitive enough. Was, for example, you have a chip in Málaga, where I live. There are many protected areas next to the water. So you go to there, you cannot just launch the anchor and keep the chip and shut down the engines from the chip. So if they are working, they produce enough noise so the system didn't work. Okay, thank you.
Hi, so first of all, congratulations on such an awesome workshop. My question is, how is the submarine contributing to Ubuntu?
That's a good question. Thank you. It's actually not contributing itself to Ubuntu. I got the question last year. What this has to do with Ubuntu? Ubuntu, you're talking about the company, you are talking about the operating system, or you are talking about the meaning of Ubuntu itself? Because this is community, what is going on. And this is part of the philosophy of Ubuntu, is sharing, taking care of people that is around the ecosystem. So this is it. This is actually the connection. It's not connected exactly with the trademark of Ubuntu.
Awesome, awesome.
I didn't mention, but I have somewhere. This works also, not this one. In the Raspberry Pi, you can install. It can be with Ubuntu. And I was already looking if I can make it in a Snapcraft, if I can make the package and snap and everything, but didn't have time.
Thanks a lot.
So you can help.
Yes, if you want to snap something for any. If you want to snap something for anything which you need for your submersibles, you can come to my workshop to our Snap Crafters workshop, you can learn snapping. And also, you need very reliable snaps for submersibles. So tomorrow, you come again to our second workshop and you learn the CI for snapping.
I will. And anyway, I have a Snap already. Yes. I have a software that I made in a Snap.
Thank you for the great workshop. Thank you for keeping the workshop room dry so that you can learn snapping in it.
Great, thank you.
What is the autonomy of the submarine?
The aluminum? Autonomy. It's depending how much work you do with it, but it can go from 1 hour, 1 hour and a half, depending. In the normal work, it's 50 minutes to 1 hour. And you have to take it out, change the battery, and take it in again. There is this version, actually, you can send electricity through the cable. Actually, I don't know if this is exactly version because of the thick of the cable, but you can do it like kind of a POE? Power over Ethernet, yeah. So this is one of the ways you can give power to the submarine, but 300 meters is a big deal. So it's more comfortable just to have batteries. Depending.
What type of license do you need?
Okay, that's a very good question. Depending on the use that you are doing. If it's, you consider it as a toy, my first submarine was a toy, actually you don't need much because you always can go as a toy. But when you are going to operate, you need marine certifications and things like that. It's not that simple, you know.
So it's not just dependent, for example, on depth. Like if I have to go like beyond 100 meters, then I have to have a license.
Actually, I can show you later some guys that they made a rover and they are sinking 250 meters through a hole in the mine, and it's not in the sea, and it's actually the same thing. To go to the deep sea, you need to go on the ship, so then you have to follow the rules of that. And you cannot throw anything that you like to the water just because of you like.
Yeah, thanks.
Okay, so remember to come to more questions.
Thank you for the presentation. Now, if you want to go under the water, then you use thrusters to push the submarine down, but would not be more energy efficient to have some tank on it and fill it in the water with water?
Have you seen my website? I work also on that technology. I was working in a system for working with buoyancy with compressor, but it's too big. And at home, I took an inflator for wheels of a car, and the maximum I could get there was 10 atmospheres, which is nothing, you dive. 10 atmosphere is just like maybe to blow out a couple balloons when it's uncompressed. So it's not something that you put a rope and wait that to come back just with that little bit of air. Especially that air gets under the water, then if you need it for managing everything, you can just run out of it. Okay, we're running out of time. So thank you very much, and don't forget to come to Málaga on June. You are all invited. We will be opening the call for papers on the end of December, the beginning of January. So thank you very much.